Aha! Back! Yeah! Let's go! Hopefully my sound's actually coming through. I should probably check me. I think we should be good. Yeah, we got good sound. Fantastic. Yeah, should be good. Should be good. I'm excited. It's nice to be back. I'm not expecting many people to show up because, I've been AWOL for like 5 months or something, which, for anyone who watches this after the fact or ends up coming around to say hi, I will be doing a video at some point to explain why I haven't been around. There's been a handful of reasons, not smallest of them all being the fact that I've just moved house. Me and my girlfriend have just bought a flat, which is nice. I'm working out of the new studio. Maybe we'll do like a little tour of this place, but yeah, so that's nice. But there's been some other personal reasons that have just meant I haven't been able to put as much effort into games and stuff, but rest assured I will be doing some stuff to update anybody who's still interested on what's happening with Square Off, what's happening with the studio. I intend on getting more videos out soon. Not smallest of all, starting with this game jam, which it's been a long time since I've done a game jam, and honestly I might get in trouble with my other developer at the studio for going off piste and doing a game jam instead of working on the project we're supposed to be working on. But I want to get back into some things, so here we are. We're doing the Wanna-Yam Game Jam, hosted by Wannabe Manisha and Sam Yam, as you can see on screen. It's going to be good fun. I'm going to try and make my entire submission in this one live stream because I mean, as you guys know, I'm terrible at finishing games, so it means we've not got many released. Funnily enough, we have actually got some released, We've got, over on the Sheepadogs, we've got 3 projects out so far. We've got Purgatory Gatekeeper, which was a game jam project that I did with other developer, Jaden, his name is. He came onto the team fully, probably sort of November last year sort of time, and has been a really, really good man to have on the team. I'm really happy that he's joined. And together we've made Purgatory Gatekeeper and Codename Tapestry, which is like a pre-alpha demo, really kind of janky roguelike type thing. And then of course Square Off as well, which is up on itch.io. You can download it and give it a play. I'll push some updates eventually, but again, we'll talk more about that in another video. So yes, today objective is making an entire jam game in basically 3 hours. And it might go well, it might go terribly, we'll see. The objective is we want to make something that's low scoped. I want to be able to spend some time working on some visuals that look nice but are simple but effective, clean visuals, and ultimately just creating a really easy, simple game loop that ties in with the theme of the jam. So yeah, theme announcement is in 5 minutes. I am very excited. We've got lots of people hanging around ready for things to happen. I'm excited. It's been a long time since I've done a game jam. I think the last one that I did was the Game Jobs live game jam. Hey, Adam's here. Hey, my guy. How's it going? Game jamming. It's going to be both good and terrible at the same time. I was just saying about the last game jam I did was the Game Jobs live game jam, where me and Jaden and another person we were working with, Alex, we made a game called Nightmare Daycare. Currently not available for download because it was incredibly buggy, but I think we might come back to it and work on it to push it out because it was actually a really fun concept. Just as an example for what the game looked like, it was basically a little daycare simulator where the children in the daycare were fully systemic or fully AI driven. They could go around picking up knives, they could like drink bleach. These kids could do like loads of random stuff that would ultimately put them in danger. It was all procedurally animated, physics driven, and we managed to put this thing together in 2 days, which was insane because I was also like down in Southampton or something for one of those days. It was an experience. I'm getting messages from you, Adam, saying that my sound is bad. I do have compression on there because usually, right, my microphone's like all the way over here, and I don't end up getting enough volume without having it right up close to my face. So I've compressed it. Let's turn that down a little bit, and maybe I'll come back to that and sort it if there's more issues. Glad to hear you're doing good though. We are, yeah. It's gonna be good. I'm expecting you to give me some good ideas here, my guy. It's gonna be an experience for sure. Lots of fizz when I talk. Let's see if I can turn this down. There we go. Might be a little bit better. Or I'll just like lean back on the microphone, try not to talk as loud. Also, don't be shy. Get those audio messages in the YouTube chat. It's good. It's good. We're gonna have some fun, you and me. Might be able to actually even get you way worse. Undo what I just did. Great. There we go. Is that any better? I don't know. We'll sort it eventually. Let's have a listen to what I'm doing because we've got some time. I can hear the fizz in there. Let's have a look here. Properties. No, not properties. This goes to show how out of practice I am on the streams, but let's get that down a bit. I mean, to be fair, I could probably not worry too much about the compression and just stick some gain on there. Yeah, maybe let's do that. Let me turn that off. It'll be because the input on this this side of the mic, not the mic, the interface is absolute trash. How's that sounding? Oh, there we go, much better. Yeah, it's the my big knob, exactly. Big knob is got a dodgy input on input 1. So I've got to do some. I can't use input 2 annoyingly because I can't switch things over in OBS, which makes me so sad. But there we go. Noise suppression seems to be working, and that's good quality. I actually have decent Wi-Fi or decent enough Wi-Fi now, so we shouldn't get cutouts. And I think we are about to go in for the theme reveal if Chrome will let me mute this tab here. It should be premiering in literally a minute. And I may have muted my music a little preemptively, but I think it's time. I think it's time. Come on. Nice. Good audio. Let's go. I'm genuinely excited. I'm feeling like I can do something cool maybe. It might be good, it might be bad. We'll find out. Okay, the premiere is beginning, apparently. Let's go. Ooh. I hate YouTube premieres because of these like weird countdowns. It's like you set it up to premiere in 30 minutes time and then it's like you gotta wait another 30 seconds. Just need that sound dampening up. Yeah, I'm gonna build some new panels. I just took my old ones to the skip because they had gone a bit not great. So we're gonna get some proper fake ones. We're putting the new desk in a couple weeks as well. Floating desk, full wall to wall on this side. Adam, you know what I'm talking about because you've been here. Right, let's see what's happening. Look at this. This is a cool vibe right here. I'm hoping for something good that I can just, you know, lean straight into. Combination. Sweet! That's brilliant. That is perfect, yeah. Okay, so combination, you know, we can do all sorts of stuff. We can, let's just turn this down a bit. Oh, good, volume's low. So combination, we can do crafting system, we can do mixing genres, we could do like all sorts of things. And we've got until the 15th of August as well. That's a good amount of time. Okay, cool. Well, I mean, my first thought is that I want to do some kind of crafting game because that feels like a good start. Let's pop open a oh, what's it called? Milanote board. And start brainstorming some stuff. I think definitely crafting is going to be good. Crafting is going to be good. You know what? Do I even want to? I mean, I should plan something, but also limited time. Puzzle meets safe cracking. First thing that came to mind is safe cracking and hacking. What's up? What kind of way did you think? With like a combination lock type thing. Yeah. That sounds about right. Wanna-Yam Game Jam. Yeah, there we go. Let's get in here and we are gonna go with mind map. Boom, amazing. Okay, let's combination. Let's get going. So over here I'm gonna have crafting game. Oh well, combine items and things. If I could type, geez, items and things. Over here, I like the combination lock type thing. What other things can we get? I wanna try and exhaust as much as possible, so that you know we can cover all the bases. I think what else. I mean, there's breeding. We had you know, like shepherd, breeding creatures, potion crafting. Go with hacker game. We've got safe cracking. Got figuring out lock combinations. I mean, the important thing as well is that we want to keep this scope relatively low, because obviously I want to try and finish basically the entire game today. Ideally, that would be the cool thing. Although the fact that we've got so long makes me think we could put a bit more time into it. You know, we'll see what happens. We'll see what happens. So, I mean, immediately when I'm thinking along the lines of the crafting game, I like the idea of having a game where you play as like almost like an overcooked type thing, but you grow the ingredients as well. So you can grow like maybe there's 5 different types of flowers, and if you combine the flowers in different orders, you can put like 2 things together and it produces another thing. Then you put that thing with another type of flower and it produces a different thing to if you did it another way around. Those kind of recipe type things. And people come along and ask for certain types of potions. You've got to combine them all, dish out orders. That could be an interesting start. That could be pretty easy to put together as well. I feel like maybe that's the route I want to go down. I think let's go. Do I go 2D or 3D? I think I go 3D because I can make 3D look 2D. 2022. And we're going to use URP, using Unity, of course, because it's Unity. Only engine I know how to use. I did try to install Unreal 5 the other day, actually, but I don't have enough space because it's like 97 gig. It's ridiculous. Like, I really want to play around with it because of all of the cool new features that it's got, but yeah, no, I don't have that much space free. Kind of insane. What am I doing? There we go. It's going to take a while to boot up, so while that's doing, let's continue thinking along our brainstorming. Can I can't move any further up in this direction. That's annoying. Let's just move all of this stuff down then. There we go. Oof, that was laggy. I mean, breeding creatures could be fun as well. I kind of like the idea of making a game where we can have this short play loop. Because we can set it so that it's like, here's a timer and you just kind of do things. Or have some timeouts on orders that come in a similar way to how Overcooked works. And I'm trying to think about, do we... I feel like I'm pretty set on the potion crafting. That's I like the crafty nature, and crafting systems aren't too crazy to put together as well, especially if there's only two things in a unit. So I think the important thing probably would be just coming up with those recipes and coming up with the base ingredients. Yeah, that's going to be. Oh, let's put the music back on as well. Maybe not super loud. There we go. Oof. Phone is loud. Jeez. Focus. There we go. Yo, so I'm thinking the plan is probably going to be crafting game. I like the idea of doing like an Overcooked style type of thing where you kind of manage the ingredients that you have, mix the ingredients together, and then use them to fulfill people's desires. I'm kind of wondering if I want to do it in this. I mean, botanical stuff makes sense to me. I feel like that checks out. Unity is just taking its sweet time to load, so that's cool. Yeah, I think that's gonna be the direction. So let's get this thing set up. First things first, we need to install some packages, because we're definitely going to use the new input system rather than the old one, because old input system just makes me sad. Sort out my layout real quick. And let's put this in high quality HD. Right, packages. So we are going to use Cinemachine, of course, because why create a camera script when we can use Cinemachine? Come on, my guy. My computer started going really slowly at the moment. It's very tragic. Yeah, don't spend 300 quid on clothes. That's not the start of the month anyway. End of the month. And you got stuff left. Do that expensive stuff. I'm trying not to spend loads of money at the moment because we're going to London at the end of the month. And I've got, obviously, you know, London, expensive. Need to make sure I got some cash. Yeah. I mean, how does it? Have they got the timeline public on like the website or something? Man, the package manager is taking its sweet, sweet time. Let's sort out my assets first, shall we? Or maybe I'll just restart the window because this is weird. There we go. So we want feel, which feel is just a little tool for creating some nice game feel stuff. You can use it to trigger events for camera shake and like particle systems, sound effects, all sorts. Makes life nice and easy instead of having to write all of that code from scratch. Very good for prototyping and very good for game jams. We are also going to use maybe the modern UI pack, because I actually quite like the modern UI pack. It's very clean. But you know, if we're going with some funky crafting stuff, we're gonna have to create some things anyway. So let's, first of all, I need to clean some space in here. Let's do a little delete on that. This one can go, that one can go. Oh, do I want this one to go? Interesting stuff in here. It's a different theme though, so we'll leave that for another day. Cool. Let's create another board. This is going to be our crafting recipes. And I think it would be cool if people could discover stuff as well. I don't think this is going to be a particularly original idea. Oh, and I mean, to be fair, we should probably think about the way that we'll get this done. It could be Overcooked style. And that's, you know, it's very simple, very fun arcade game, which is perfect for a jam in terms of, like, you know, achieving high scores, quick play time, easy to understand, that kind of stuff. But also maybe we want to do something like what Bracky's did with Crafty, where it's like a doodle god type thing, you know, the drag and drop, combine elements, all that jazz. So that's something to keep in mind. Either way, we definitely need to make sure we're thinking about here's the ingredients as a base, and then how do we merge those together to create different things. We don't need nice vibrations, don't need the readme, we need the feedbacks and the tools. Do we need the tools? We'll keep the tools. We'll keep the tools just to be, and you know what? We'll take nice vibrations just to be safe as well. Yeah. So let's look at some herbs. I guess we could keep it real. Oh yeah, how do I want to do this? Definitely want to go with crafting. I'm feeling quite happy about crafting. I mean, what would be really cool actually, to go back to your idea, Adam, about combination locks, is if we could do something like keep calm or keep talking and nobody explodes, where it's like you get a booklet with a load of instructions and then we generate some kind of combination lock based on those instructions. You use those to figure it out. Alan's here. So, my dude, we are game jamming. Theme is combinations, or combination singular. Where's the actual announcement bit? It's going to be somewhere like here. Yeah, there we go. Combination. So we've got, as we see here, we've got combining items and things. We've got combining genres. We've got combination lock suggested by Adam. Some kind of hacker game, safe cracking. Breeding creatures. Go back, hit the re-up on Shepherd, you know. It's a lot of different options that we could, or a lot of different roads that we could go down. Just gonna crack the window quick because it's toasty in here. Chemistry, yep. Comes under the same kind of... Ooh, that could be nice from an chemistry. It could be nice from an art style point of view. If we think about like bonds, and we could do something fun with physics and like, ooh, that could be cool. And like throwing atoms together and they combine into like new elements and discovering elements and things. Oh, that could be quite fun actually. Oh, Alan, you've sent me down a rabbit hole that I love and hate at the same time. That could be a cool thought, though. We could do something like discovering elements in a periodic table or something like that, and have it. Yeah, I like that idea. Oh, my window just broke. Nice. Okay. So, remind me how chemistry works. You have atoms and they have bonds. The bonds can be strong or weak. And they're covalent bonds. That rings bells. That's not how you spell basic chemistry. I mean, actually, we want chemistry bonds. I mean, usually it's like electrons and neutrons, isn't it? Oh my days, right, okay. You know it's gonna go well when you're sitting around on Wikipedia looking at bonds in chemistry. Yeah, strong bonds. Oh, see, this is making me think if we could do some kind of factory game, but also we don't really want to do a factory game. That's going to be quite high in scope. I think it's going to be some kind of sandbox discovery game, where you throw things at each other and they blend together. Yeah, cool. We're going to go with that. So we're going to do something visually kind of similar to how the background in Square Off works. We'll create some particle systems to give the illusion of some depth so we can pan the camera around and fun stuff happens. Before we do that though, let's get some more packages imported. So we definitely want modern UI if we're going to go down this road. We'll keep the animations and the fonts and all that jazz. Won't have the scenes. Keep the scripts, keep the shaders, and keep the textures. Yep, we need all of that jazz. Don't need the readme. Cool. Import that. Yeah, chemistry. I like that idea. And, you know, I think... one sec. Text Mesh Pro, we need that. Yep, import that. I think we could probably do... like, I'm not too worried about focusing heavily on making the game particularly fun, in the sense of, like, it doesn't need to be super crazy... like action magic. I'm thinking we can just make a game that's kind of like, the fun should come from the discovery side of it. So I reckon what the plan should be is that we have a periodic table of a load of stuff that's locked, and like the objective is to just discover all of these elements. That sounds like a good plan, and we can make it Fusing elements should be really, I say really easy. It should be kind of nice. We'll do some proximity checking where we have atoms, or yeah, we'll have atoms, and when those atoms come within certain proximity under certain conditions, we can do a check for if the elements should combine. And then we can fuse them together using some cool spring joints and some fun physics stuff, and we'll do like clicking and dragging and stuff like that. Yeah, I'm becoming increasingly excited about this this project or this idea as we get deeper in. So we of course are going to install Cinemachine, as I said, because you know we want to be able to do cameras easy. Trying to think, we need the new input system definitely, because we want to be able to yeah, use the new input system instead of the old one. It'll be a bit nicer, and we can integrate it with the raycast system. I mean, it would be nice if I could do with like another camera, so I can get like a desk cam and be able to pull out my notebook and sketch out plans, because I don't have a drawing tablet yet, or at least I don't have my own. Me and my brother used to share one, but he's got it at my parents' house, which is obviously not ideal because I could do with that right now. Man, I've got a lot of game ideas in this notebook. I need to find a blank page. So I think I'm trying to think about what the best way to do this kind of thing will be, and I think it'll be a case of if we have a menu where you can spawn things, so maybe when you bring up your periodic table or your element table, it'll have electron, proton, neutron, that kind of thing. Maybe there's like an atom builder. I'm trying to think about how I want to split this up to have different atoms, or do we want to build, I guess we want to build molecules, don't we? And then different molecules can combine to form other molecules, and we're just going to make up some fake molecules because I feel like it's going to be far too deep if we look into the world of actual physics. Or maybe it wouldn't be, maybe it wouldn't be. I think two things that are going to be tricky with this is, one, how do we check when things have actually reached a point that you've got some kind of molecule, some kind of element, and two is going to be, how do we stop people from just trialing and erroring it, because there's got to be some logical progression, right? So we might have to think about those kind of things, but I'm getting ahead of myself. Post-processing, we've got post-processing, it comes built in because we're using URP. Yeah, cool. So it's just the input system. Nice. That's going to require me to restart my editor, so we'll sort that out in a minute. Cool. Yeah, I need to figure out what the approach is. What's the approach here? I really like the idea of being able to kind of just fling like drag and throw different molecules at each other, and maybe it needs certain velocity to be able to like combined with certain things. It's like certain energy thresholds, that type of thing. So you've got to properly like sling this thing. Yeah, that could be fun. And then when stuff collides, we can maintain some momentum, treat them like physics objects, but if they hit each other with enough velocity or they get close enough together, we'll create a joint between them, and be able to build out these really interesting kind of molecular structures. That could be fun, yeah. And then I figure maybe we can save certain molecules. So if we've got this periodic table where you discover things, it's like we need some way of checking molecular makeup. Yeah, this is gonna be big brain programming right here. Hopefully I'm recording this as well. Am I recording it? I am. Good. Because then we can make a devlog, and devlogs are always fun. Right, let's start off with some art styles, shall we? So I figure everything is going to be made up of spheres and go on, you can do it. Molecule. Come on, Unity. I need my glasses as well. I have no idea where I put them. They're probably in my bedroom. Molecule. Let's just center him out. And we'll probably have, I guess we'll use like line renderers between molecules, and we'll have to have some way of keeping track of what molecules are in like a structure, and then connecting them as they need to be connected, because we want to make sure that we can have like different types of bonds. So these bonds that have like 2 between them instead of just 1, and even 3 between them as well. Yeah, this is gonna be cool. So maybe we'll have like a basic set of elements, and we can combine those elements in different ways with different bonds to form different molecules. And the objective of the game is just to discover all of the molecules and mess around with them, and maybe we can make molecules do some cool particle effect things or something. So let's start off with our main camera. We are going to keep it perspective, but we are going to massively drop that field of view to like 15 or something. Back it out to like minus 100. Yeah, maybe minus 50. 75. We are going to get rid of the skybox. We want it to be just a solid color. We're going to go with like a nice shade of gray because everybody loves gray. Maybe we'll go with like a kind of dark purple sort of shade. I mean, we'll grab a proper color scheme later. And then as far as the visuals go, we've got 2 options. We can either use an unlit shader, which, you know, I'm kind of leaning towards doing that. That could be the way to go. Or we can go with this nice little technique which I got from our lords and saviors, the Sock Pop Collective. Which, if you go into the lighting settings on Unity, the default lighting settings are kind of trash. So we'll go in here, we'll remove the skybox, we will set our environmental lighting source to a solid color, and we'll just make that white. And we also want to go down here and change the reflection source to custom, but now we get this like kind of flat look on things. And then if we just go on our directional light, change this to color, and set the intensity to like 0.1 or something, we basically get an unlit shader, or an unlit feel, but we still get a little bit of depth and shadow. I'm just going to go on here and turn off our global volume because it kind of, the default one kind of sucks. Make a graphics folder. We're going to make a folder for materials. And I'll tell you what, let's do both, just to see kind of how we're feeling. Let's get a unlit molecule and a lit molecule. Create a material. Unlit molecule. No, that's not what I want. Molecule. Let's make this URP. We're gonna go with unlit because this is the unlit one. Drag you onto you, and then duplicate this for the lit molecule. And this is going to be universal render pipeline simple lit because we don't want to worry about anything like brain, anything like specularity or metallic, how metallic it is. We don't want to deal with the PBR stuff. We just want to worry about the actual shading on here, and they actually look basically identical in here. If we take our sunlight though and up the intensity somewhat, is that not going to change anything? Have I? No, I haven't. They are different. Why do you look the same on my thing? Yeah, you're you, that's fine. Yeah, we can keep it kind of subtle if we do this at like a 0.8 or 0.75. Oh, we got to take it quite low. So let's go full intensity and we'll just make it kind of gray. Maybe like that kind of vibe. We do have cylinders as well, so we can actually... I kind of like the feel of having it lit. Because what I want to be able to do, if I just create an empty molecule... let's get rid of this one real quick. Drop you under there. We'll drop our cylinder under here. I'm going to put the circle at 0, 1, 0. Make sure we zero this out as well. Cylinder can be at 0, 0, 0, but we're going to make it like 0.1 on these axes. Maybe 0.25, a little bit thicker. And let's get ourselves a bond material. We'll make the bond white. And let's make our molecules like kind of red, I guess. Yeah, maybe like this kind of color. I mean, we can have different colors for different types, and this background is should not be purple. But it also should not be super dark. I don't like it super dark. But super light just hurts the eyes. Screw it, we'll go with super dark for the time being. Okay, this, stick it at -1 just so we can get an idea of what this thing looks like. And then, when it's floating around space. Maybe I do want a little bit more depth on this because this feels a bit close. I mean, something we can do here. Let's add a rigid body. Hey, Cal's here. How you doing, my guy? We are game jamming today. Making a game about chemistry. Which is, it's going to be fun. I don't actually want the rigid body on that one because we want all of the elements to be separate, and we're also not going to have a cylinder. We're probably going to use a line renderer, which is fine. We need some kind of way of making sure molecules are like encapsulated somehow. We need to keep track of what's what, because then we'll have some line renderer that connects the two of these, and probably like a spring joint or something. Which means molecules also need rigid bodies. Hey, well, let's delete this one. Let's make a prefab. This is the most scrambled game jam approach like ever. If we have this molecule, we can connect our rigid bodies together. Like so. And do I actually remember how these things work? The answer is no. Woo! I need to make one of them kinematic. And we're also not going to use gravity. We're going to give them some drag, maybe like 2. Let's get one of our molecules and move it over here. Here we go. So we got some gizmos on the spring. Do I want them both to have spring joints? There we go. So now we get this like these cool like connected things, and we can. What's my null reference exception that I've got here? Nothing that I need to concern myself with. We can set things like the stiffness or something. I don't want it to just infinitely orbit my other ball. We're going to have to look into how different joints work, because that's ridiculous. But that's basically the approach we're going to take to build our molecules. We're going to just have some things, and we'll have a script that lets us drag and drop stuff. Cool. Okay, little bit of a plan in shape. This is good. Is the game going to be playable afterward? Yes, it is. I'm glad you're doing well as well, my guy. It's good to hear. Always good to hear. But yes, game is going to be playable. I'm planning on doing the whole thing today. Probably not going to happen because I'm way too much of a perfectionist about how I like my projects to feel. But you know, we're gonna try and work as fast as we can to get this where we want it. Can I delete you, please? Thank you. So let's reset this guy to 0. We are going to remove that joint for the time being. I'm just going to go here. I'm going to look at joints in Unity. And actually, you know, we can just watch this video here because I can never for the life of me remember how the different joints work.
We will talk about fixed joints, spring joints, hinge joints, character joints, and configurable joints. Yes, we're talking about all of them, and you can find the time codes in the descriptions so that you can skip all the parts you don't need. At the time of the recording, you can't find any tutorial on YouTube that covers up all the joints of Unity. So
appreciate it, my guy. Appreciate it. I look forward to hearing your review. Oh, not the volume. I want to just skip ahead a whole bunch.
So everything can be joined. Rigid body, so connected. Here we have force. A brake force is 3. Let's create enable.
So this is the fixed joint.
Let's create another cube.
And I think this is basically like parenting.
This is a
so when it's connected to a fixed joint, it just moves.
The other rigid body
will
also be moved by Unity because it is connected to the connected rigid body. And here is my free rigid body. I can't move it into the other box.
Cool. So fixed joint isn't going to be the one we're looking for.
Is applied.
I don't think spring joint's going to be the option either, because that is like a proper spring. It should make it kind of bouncy. Ooh, did I just skip to the end of the video somehow? I did.
And I think we can start right there with this one. And
yeah, there we go. So it just kind of springs up and down.
Right there. So when I move it, the anchor is right there. I can set the anchor. This is the first one to the middle. And as you can see, the anchor is in the middle. It behaves a little bit different. So it rotates a little bit more. If I set the anchor back to 0.5, it's again anchored at the top, and you see the brown spot there.
Okay. So yeah, probably not the right one either.
During runtime, yes, as well, because this is a connected one. If I do not,
maybe we do want to use fixed. I suppose it will be for different types of connections. We could use a different type of bond or a different type of joint even. So for a weak bond, we could use a spring joint, and for a strong bond, we can use a fixed joint. Wait, what's just happened there?
It's still a joint, but it's not connected to this.
Okay, so we can have a spring joint on a thing without it being connected to anything.
And let's talk about the other values.
And it'll just kind of spring around.
You can see it's a little bit stronger.
Okay, okay, that's cool.
You can increase the damper, decrease the spring again, and you see it's moving way slower. You see it's damping. It's not that way damper. You can see.
So yeah, more dampening makes it move slower. That's cool.
Increase the damper, decrease the spring again, and you see it's moving way slower. You see it's damping. It's not that it bounces so often. So if I set the damper very high, let the cube fall. Oh, it's not falling anymore. It's so. And now you see there's a high damper. So these are the values spring and damper. They are returning and occurring in all the other joints. So keep in mind this is spring.
Okay.
The force that is applied to the rigid body to reach a specific position, and the damper is a damper, so it damps it on the way to the position. If you have a spring and a damper, there's often a min and max distance, and this indicates where the force is applied and where the position or the target position of the rigid body is. For example, now it's directly in this brown spot. If I set it to 1, the target position is in the circle around the brown dot, so it's either here or up here. The force is applied always to the nearest position, and the box tries to be around in this shape. Next up, hinge joint.
So that's not going to be the one. We don't want the hinge joint.
So connected rigid body and move semi-axis. I can this which is maybe interesting. For example, can set it to 0.
I think it is going to be a spring joint, and maybe we
middle of the box.
We connect things by actually, when something hits into something else, we can detect that collision and say, okay, I've collided with this, let's make a connection there, and that way we can just connect stuff to other things, and anything that is connected to another thing, we can work out the molecule from that.
Up a bit. Now it's hanging around here, and now we have the same concepts coming over 100, say as to go to the target position with the force of the spring. I can set it to 90 to rotate it around 90 degrees. I can set it to 108, let it, and then you see it tries to also, and the
that way we should be able to fling around. Yeah, this is going to be fun. Okay, let's make a folder for our scripts, and we'll start off with molecule logic. We'll make a class for molecule. Pop this boy open. So just to kind of go into my how my brain's working right now, what I want to create, I want to just create the baseline for being able to click and drag on a molecule to move it around, and then when you let go, it will maintain its velocity for that. We'll give it some damping as well, so that it doesn't just fly off into infinity. It's like it'll have a limit, and maybe we can control that with like a density parameter or something, some information. And then we want to make it as well so that when it hits into something else, it's going to create a bond between itself and the thing that we've just hit. And we'll probably make a class for bond as well. Just so that we can kind of keep track of that. Are you gonna zoom? Gonna zoom a little bit more? There we go. Yeah, we'll probably want to keep track of bonds in their own class as well, just so that we can not duplicate our connections both ways. It's like if this is connected to that, we only need to draw the connection once. We don't need to draw it both ways. We should keep track of things being connected together though, so we'll work something out. We'll work something out. Okay, so we want to have a reference to our spring joint, which we'll call, let's do this properly as well. We're going to maintain some decent code. So serialized field, we're going to have a private spring joint, which is going to be our connection joint, and we can control parameters of that based on like other stuff. We'll also have a serialized, let's go with a list of molecules, and this is going to be our connected molecules. Set this equal to new, which is shorthand in C# for just creating a new list so that we make sure it's not null. On our awake, let's also just make sure that that list is empty, because we don't want to have maybe we do actually. No, we're not going to make sure it's empty, because we might want to spawn some molecules that already have connections, and we might want to be able to set these when we do some stuff. So you know what, let's have a public void create connection, which will take in a molecule to connect, and in this we can't have a spring joint. We might need multiple spring joints to make sure all of these things can be connected. Okay, that's fine. That's fine. So what we'll do is, first of all, we will add our, we'll say if connected molecules dot contains molecule to connect, then we return. If we're already connected, we don't need to connect to it again. Otherwise, we want to add this new molecule to our connection, and then we want to add ourselves a spring joint to connect to that molecule. So let's add component, game object dot add component spring joint, and we're actually going to cache this. So connection, and we probably want to cache our connections in a list as well, so that we can delete the spring joints when stuff gets disconnected. Let's make a serialized field of private list of spring joints, connection joints, add our connection there. I suppose it's going to be kind of difficult. Maybe let's make a public struct connection info, which will have a spring joint connection, and then public molecule A and molecule B. We'll make sure we pass this info in as well. So spring joint connection, molecule A and molecule B. Connection equals connection. Molecule A, sorry, equals A, and molecule B equals B. And then yeah, we'll have a list of this connection info, and that way we can do a check on this thing to see if molecule A or molecule B is the thing that we want to disconnect, or if we select that connection, then we can break it. I'm not sure how I want to do connection breaking yet. We'll figure that out in a bit. So this is now going to be connections. We are not going to do that. We are instead going to create connection info. Going to be a new connection info. We are going to pass in our connection. We're going to pass in this, and we're going to pass in the molecule that we want to connect to. And then we are going to add that to our connections. Nice. I'm wondering if this should be a map or something, because then we can map the info to the thing that we're connected to, but we can come back to that in testing if things are a bit weird. Cool. So then we want to set up our spring joint. So we're going to say connection dot connected body equals molecule to connect dot RB. Let's make a field for that. Rigid body RB, and then we'll give it a public getter as well. So public rigid body RB get return RB. There we go. We also need to make sure we set some parameters on the rigid body as well. Although, to be fair, that should kind of be enough. So we'll do a public void on collision enter. We are going to do a if. Let's have the molecule hit molecule. And we will say if hit molecule equals collision dot get component game object dot get component molecule is not equal to null. We'll create a connection with the molecule we want to connect to. Hit molecule. Cool. I feel like that should basically be it. I think the only other thing that we want to do is we want to somehow create like a line between these, right? We want to create some symbolization that we've connected to a module, a molecule even. And that's probably going to be by creating the bond object, which I guess should be done in our connection info, because we only want, or no, we only want one bond. Because the problem is this method's going to get called on both the thing that we've thrown and the thing that's been hit. They'll both create their connection. So I guess we want a way of verifying which one should be the parent. And I'm not sure how I want to do that yet. I mean, we could just fire off an event. Yeah, let's do that. Let's do that. Let's do a public event action. Make sure we're using system, and this is going to be molecule, and we'll call it on connection created. And that way we can create some other class that subscribes to this, which creates our bond visuals. And it'll just keep track of connections that exist. If the connection already has a bond, yeah, that makes a lot of sense. I think just for the time being, though, to make sure it's working, let's do an on gizmos, on draw gizmos. We will gizmos dot color equals color. Let's go with green. And let's do a gizmos dot draw line. And we'll do it from our transform dot position to our connected. We're gonna have to do a for each. For each molecule in connected molecules. Whoa, what is going on there? Semicolon. Molecule.transform.position. Cool. So the last thing we want to do is actually make it so that we can click and drag these things. And we do that by implementing the I pointer drag handler interface. What's it called? So we've got I pointer down, I pointer up, and I pointer. I want a drag. I drag handler. Yeah, cool. And a drop handler. We just want the drag handler. Let's implement all three of these. Actually, we want an I pointer enter handler as well, and I pointer exit. And these are going to be what we use to control throwing around our things, and then also controlling a tooltip so that we can get information about the molecule that we're hovered over. So this is going to be where I struggle infinitely with figuring out how to click and drag a thing, because what we want to do, we don't want to just set the position of the thing to the position of the mouse cursor. We want to figure out where the mouse cursor is and then apply a force in the direction of the mouse cursor on the thing. We almost want to create like a joint between the mouse and the molecule so that we can sling it, you know. And that's going to be the interesting thing. I mean, to be fair, no, because yeah, we want to affect the velocity of the rigid body. That's the important factor. So maybe we just do that. So we want to get the position of the mouse in the world first of all. So we could do that by doing var mouse pos equals And actually, this is going to be where we need to create some controls. So let's do that. I'm going to create some input actions. For controls, we are going to generate a C# class for this so that we can access it. Let's pop this open. And call my action map player. And let's call this action mouse. I guess. You know what, is this what I want to do? You're going to be, yes, it is what I want to do. You're going to be a value. Control type is going to be vector2. And you are going to be pointer position. Yeah, pointer position. That's what we want. Hey, Els here. How you doing? Glad you could come. We are making science for a game jam. And I think what I might do is I might try and get this click and drag thing set up, and then we'll take a break, and then we'll come back and do some more things, because I think let's override, apply all these overrides. We can actually go in here, get rid of the serialized field on our rigid body because we don't need to set it in the inspector. Instead, we can stick a little tag on here, require component type of rigid body. That just forces it to have a rigid body, and then in our awake we will say RB, which should be an underscore, RB equals get component rigid body. Let's rename this real quick to have an underscore, maintain proper naming conventions. Cool. Oh yeah, I need to actually finish up this line. Let's just comment it out for the time being. How do I want to do this? Let's make sure we've got a physics raycaster on our camera so that we can actually, you know, click and drag things in space. And you know what? I'm just gonna put some debugs in here. Debug.log, dragging molecule. Oh my days, I cannot spell. Oh my gosh, I spelt it wrong. Molecule. L, not an R. Molecule released. This is going to be molecule grabbed. Or molecule clicked, probably. No, grabbed. And then this is going to be mouse left, molecule. Molecule isn't going to feel like a real word soon. Mouse entered, molecule. Cool. So theoretically, theoretically, and this is very theoretical, we should be able to create multiples of these molecules and smack them into each other, and they should do the thing. We're not using gravity. We want a drag of like 5 maybe. And you know, maybe I'll make it so that when you click on a molecule, it will just add a force in a random direction. That sounds like a good plan. So on pointer down, let's do rb.addForce. And we're going to do new vector 2, not vector 3. We can do a vector 3 because I want it to not move on the z-axis. So we'll just pass in random.range between 0, -1, sorry, -1f and 1f, so it's inclusive. Random.range between -1f and 1f, and then 0. And we're going to use impulse, so it's instant. And then we're going to figure out why it's complaining about random. Oh, it's because I'm using system, and we want to use Unity engine.random. So maybe I'll just make this a Unity event. Get rid of that. Get rid of the system qualification. And now our error is gone. Cool. So theoretically now when we click on this thing, it should just move a little bit. And I'm actually, you know what, I'm going to multiply this entire thing by like 5. I'm going to normalize it and then multiply it by 5 so that we've got, it'll actually do the thing. And because of the drag, it should kind of come to a halt eventually. We want to make sure that we are frozen on the z-axis. We don't care about our rotation. Rotation is cool. You know what? Maybe we don't want to be frozen on the z-axis. We can make some way to move forwards and backwards. That should be fine. Not sure how yet. We'll work out. Maybe Q and E is zoom in and out. That's usually the controls, right? So let's see if this actually works. And if it doesn't, it's going to be because I've messed up something to do with the way that physics is set up. And that is exactly what has happened. You can see we're not getting any stuff in our console. So I'm going to do a quick hop over to my trusty friend, the internet, and we're going to Google how to iPointer enter iPointer handler 3D object Unity. Let's have a look. I need the event system. There we go. We'll replace this with the new input system, and that should actually throw out some events now, I think is the idea. Got the collider. And yeah, we want physics raycaster. Cool, that should do it. That should do it. Let's find out if that makes the difference. Yay, there we go. So if I click on it, I don't know if it's actually adding the force. I mean, it should be. Maybe it's because the drag is just way too high. If I set that to 0. Nope. Still just not getting any force added. That impulse. Just make it massive. Add 50 as the force and see if that makes a difference. I want to make sure that the force adding works, and then we can move on to actually making it add the force in the right direction, which will basically be add a force towards the mouse. type vibe. Come on, my guy. Why are you not getting any force added to you? Oh, is kinematic is checked. I don't want it to be kinematic. I just want it to not use gravity. Kinematic, it's not going to add any force. There we go. Oh, look at that. Oh, and he's gone. That's great though. That's pretty much perfect. If I take that back down to 5, and let's make a few of them just to see how everything's working, and maybe we can get things connecting as well. And I think let's make a physics material for some bounce, just so they can hit each other and bounce off. Create. Where is physics material? Physics material. Molecule. Spell it right this time. We're going to have the bounce combined to maximum, friction combined to minimum, 0 friction, and the bounciness we're going to set to like 0.75. Let's stick that on our molecule over here. Apply our overrides. I'm going to save the scene just in case Unity crashes, because we all know it has a tendency to do that sometimes. Duplicate our molecule a whole bunch of times, and we should be able to click on the things. They'll bounce around. If they hit each other, we should see a bond form. Jeez. Let's try it. Yeah, there we go. So our molecules are connected now. And we can see when they hit each other again, we're not getting any more connections, but I can add forces to one of them and yeah, that's perfect. We just need to make sure that they maintain some offset so we can control that somehow. And I like the slight 3D feel that everything has. What I should be able to do too is if I can manage to get these guys kind of close together, which I don't think I'll be able to because they're like miles apart, but we should be able to form like a chain. Come on. Go on, you can do it. Come on, we're getting so close. There we go. Now we've got a chain of molecules, so we've got all 3 of these guys connected. Yeah, nice. Oh, I love it when things work, and they're maintaining their offset as well, so we actually do hold the shape. Oh, perfect. That's brilliant. Tell you what, let me drag this over here and smack it onto this one as well. And I think if we do that, yeah, now we've got 2 connections. Now these are all connected. And I think we should be able to... yeah, we can create connections between all other things, and they do some crazy stuff. And now if we drag one around it, it pulls the other ones with it. Which is, that's pretty cool. That's pretty cool. Okay, so let's, first of all, I want to figure out that distance. I think it's the min distance. We need to set that to like 1.5 on all of these. Min distance 1.5, max distance also 1.5. Now these things should be like miles apart from each other, but they're not. Let's give them some dampening of like 2.5. Okay, so I think the main problem is that we've got them all tangled now. They're all connected to each other, and that's not what we want. But this is okay, this is good. So what I'm going to do is I'm going to make it so that we can check here if we right click on the thing, then we'll break all of its connections. And that's going to be interesting. We're going to have to create a little method public void break connection. Because we'll have to break the connection on both ourselves and the thing. If event data dot is it button? Oops. Let's find out how we do this. I pointed down handler check which button. I mean, it might just be worth looking in here, and we can look at. Can I do that? I can. We're actually going to check if it's right. And we'll, you know what, let's, that's fine. So then in this right click, we will break all our bonds. Let's update our spring joint as well to have the appropriate distance. So when we create our connection, we want to say connection dot min distance is equal to 1. Connection dot max distance is equal to 1. And that should keep our connections, our distances nice and far apart. When we break a connection, we want to know what the molecule molecule to disconnect. And I think this is probably going to be where having this as a map is going to be much more helpful than having it as a list. Oh, dictionary. There we go. And we are going to map a molecule to connection info, and then when we add our connection info, we will map it to the molecule to connect. Like so. That way, when we break our connection, we take in the molecule to disconnect. We are going to do if connected molecules dot try get, wait. Oh, it's connections, not connected molecules. Connections dot try get value molecule to disconnect out connection info connection. So if we get something from there, we've got our connection. We can do a connection dot break connection, connection dot molecule B, because it will be the molecule. Wait, no, it will be molecule A. Yeah, connection dot molecule A dot break connection, passing in this. And then we want to do connected molecules dot remove connection dot molecule B. That's going to be B, that's going to be A. And then connections dot remove molecule to disconnect. That should do it. So when we right click, we can simply do a for each connected, for each molecule connected molecule. No, let's just call it a molecule. Keep it simple. For each molecule in connected molecules, we will break connection molecule to disconnect. And just to make it a bit fancy, not molecule to disconnect, sorry, just molecule. To make it a bit more fancy, let's also add a force away from the molecule that we've right clicked on. So we'll go molecule.add force, molecule.rb, sorry, .add force. And we are going to do the molecule dot transform dot position minus our transform dot position, and we'll multiply that by, I don't know, let's go with 10 maybe. I guess we'll probably do it by the strength of the bond at some point, and we'll do that as an impulse as well, so that it's kind of explodes outwards. That should be quite nice. Let's test that, shall we? Let's see how this is working. We should be setting our spring joints as well. Oh, that's what we want to do. We want to make sure that we remove the spring joint as well. So before we remove our, let's do game object.remove component. Can I not remove a component from a game object? Remove component unity. Oh, I do just destroy it. Yeah, okay. Destroy. And then we're going to do connection dot connection. Nice. And then garbage collection can make sure that we don't have access to that collection anymore. We're probably going to get some like null pointer exceptions going on, but you know, that's okay. There we go. These boys are connected. And if I right click on it, oh, it crashes Unity. Okay. Okay. Why is everything so zoomed in out here as well? I didn't know I could do that. I have no idea why Unity just crashed. It's probably something in my code. I think it might be like, I mean, I suppose there's only one way to find out. Let's just test it again. See what happens. I don't like how those springs are feeling. They feel a bit weird at the moment. So let's figure out what's going on there. Do some clicking on my molecules, get them connected. Go on. You know you want to. There we go. These guys are connected now, and they are inside each other. That's not right. I need to figure out how to make these springs like stiff. Oh, I don't know yet. So if I right click this, yeah. That is definitely the thing that crashes Unity. Okay, let's see if we can figure out why that's a thing. I saw some failed to do something error come up. Let's turn on the lighting in here as well so everything looks how it should. And I also want to make sure that we up the intensity of this light appropriately. Maybe to like 0.2. Yeah, 0.25. And that gives us, you can see we've got like a small bit of shading on the molecules now. They've got like a little bit of shadow, which is exactly what we want. We want it to be kind of flat shaded, but kind of not at the same time. It's definitely, this is the thing that's not making it not happy. Oh, is it going to be because we're editing our molecule list inside of here? We can't do that, or you're not supposed to do that. Let's do it as a normal for loop instead. So for int I equals connected molecules dot length not length, sorry, count. We're using a list. Count -1. We're going to work backwards so that we don't get any weird issues. I is greater than 0. Greater than or equal to 0. I minus minus. Connected molecules. I. Well, let's just cache it. We'll do var molecule equals connected molecules I. And then we can just maintain that. So I reckon my logic is probably in this break connection method here. So if we have that value, if we have that thing in our what's it, I suppose we don't need to keep track of because we've got the molecule that we want to connect to, or the molecule that we're connecting to ourselves there, and we know that we're ourselves, so we don't actually need to maintain that information in this struct. We just need the spring joint. That's fine, because we know that we can get rid of this. Then instead of connection info, we're just going to add our connection spring joint connection. And then we can do molecule the disconnect dot break. We can destroy our connection. Gonna remove the molecule to disconnect. Yeah, cool. That should be fine. So yeah, that should be fine. If that's what's causing the issue, I'm confused as to why, and I hope that I was going to say let's put a breakpoint on there. But you know, I like to live on the edge. Cool, let's see what happens. I mean, they feel the movement is basically bang on where I want it, almost. I think I might just take down the damping a little bit. And there we go. So these two are connected now. If I turn on the gizmos here, we can actually see that connection in the game view. And if I right click, it crashes. There it is. Yeah. Why? Why do you crash? I imagine it's got to be some kind of recursive thing, right? It's going to be, I'm like calling, yeah. That's exactly what the issue is. I'm calling break connection on the thing that I'm asking to disconnect, and then the thing that's asking to disconnect it, and it's ping-ponging back and forth. So we want to make sure that this doesn't get called both ways. I mean, maybe I just also do molecule dot break connection this here like that. That makes a lot more sense. Instead of calling it in break connection itself, we break connection on us and we break connection on the molecule. That should do it. I think that should do it. We're going to run until 4 and then we're going to take a little break. I may or may not be back later. To be fair, I reckon we could take a little break and then maybe go until 5 and then we'll call that a day. I'm increasingly feeling like I want to spend more time on this idea because I want to actually do it kind of good. I like this idea. Shout out to my boy Alan for saying chemistry. Go on, that was almost a connection. There's a connection. Get our gizmos on and right click. Hey, there we go. Let's get some like multiple things connected together. And we can see the effect, and it's you know what? Let's do it in the scene. That's just, stop messing around, throwing balls around the place. Shwee. Bong. Those are connected. And let's bong. This one's connected. So now if we right click on here, nice. That's fun. That is fun. And if I make a connection like this kind of thing. And then we're gonna disconnect this one. It actually splits apart. That's good. That's cool. I like that. Sick. All right. So we've got 30 minutes before 4 o'clock. So what we'll do in those 30 minutes is we'll set up the being able to click and drag and throw the molecules about the place. Before that though, I want to do some visual things because I want it to look a bit nicer. So we are going to make a sprite where, oh my days, I'm so blind. Under graphics, new folder, sprites. Going to create 2D, no. Oh, there was a way to do this. Can you not make sprites anymore? I guess you can't, unless I'm just being incredibly blind. Would it be under Legacy? No, cube map. Um, Bummer. All right. I'm going to show you a little trick here. First things first, let's find a color scheme. So we're just going to go to, I think it's, oh, it's coolers. That's it, coolers. And we're going to get ourselves a nice pastel-y, science-y kind of feeling color scheme. Do I want, no, not this website. It's not low spec. What's it called? There's a website that's just got loads of color schemes. Hunt maybe? That'll do. We want pastel because your boy loves some pastel colors. And I think I want to go with one that's got some complementaries. This is quite nice looking. Copy this. This is going to be our... I can delete the unlit. It's going to be the color of our molecules. Nice red. Our camera, we're going to use this light color, which might be absolutely hideous on the eyes compared to the gray. Oh yeah, it's kind of bright. Let's turn our global volume back on again. The problem I have with this is it just kind of makes things look icky. You know what I mean? Like, it just doesn't look quite as nice with the tone mapping on there. It just looks, it looks dull, it looks muted. But it's also like super bright with the, without it. I mean, I'll leave it off for now. I'll leave it off for now. I'm gonna keep the vignette though. We're just gonna make it a little bit less intense. We want this kind of vibe. 0.35, 0.25, yeah, cool. And then the bonds, let's make bonds like orange, I guess. Or maybe we make the background, maybe we do make the background dark. And there, we'll come back to it. I'm just going to put the color in there for now. So we've got some bonds, and then yes, trick. Background. We are going to create a particle effect. So effects, particle system. And we are going to set the doesn't matter what the duration is. Lifetime we can keep at like 5. We are going to get rid of the start speed. It'll be 0. And we're going to change the emission shape to, I think, a square, rectangle. Yeah, cool. And we'll rotate it through 90 degrees on the x-axis so that everything's on our thing. And we're just going to make this thing absolutely massive. So like, we're talking outside the camera massive. We want it to take up the entire screen. Make sure we are zeroed out. We'll have our start size. I want to make sure it's smaller than the atoms. So we'll do like between 0.8 or 0.75 and no, not 3D, 0.75 and maybe like 3.4. Yeah, let's go with that. I'm going to change the material to our sprite's default because I don't have a circle at the moment. Though that said, I wonder if I can just use a circle. Ah, perfect. Perfect. So now it looks like we've got these kind of bloomy circles going on, and we are going to make them our bond color, except it's not going to be exactly the bond color. You know, no, we're not. We're going to make them the background color. Background color, and then we're going to darken it up a little bit. Maybe like 80. Give it a little bit more saturation as well. And we're going to just drop the alpha to about 40, I reckon. Yeah, something like that. And we'll do color over lifetime so that it fades in and fades out. I want to make sure I'm changing the alpha. You know what, let's have 2 nodes here so that it fades in, stays around for a bit, and then fades out. We will actually, you know what, we will give them a bit of speed. We'll do a random between 2 constants, and we're going to go between 1 and 2. You know what? 2 and 4. Is that actually what I want to do? No, it's not. I want to do a velocity over lifetime. Like that, there we go. This is going to be local, and maybe I'll make that a little bit more subtle. 0.25, negative 0.25, and then 0.25, negative 0.25. And I do want these to be a little bit bigger. There we go, that's nice. And then we, the trick here is that we simulate this in world space rather than local space. World. And then we move it back a little bit as well so that it's not interfering. Move it back to like 2 maybe. Duplicate that. Move that back to 5. And we're just going to make these ones ever so slightly smaller. So like 0.65 to 0.3, and we'll make them ever so slightly darker as well. More saturation, darker color, bring the opacity down even further so they're like real subtle in the back there. But we want to make sure they're like obviously different than the ones in front. So now we've got this little background kind of thing going on. Parent those to the camera. And now if we hit play on this and I just move the camera around a bit and we focus on the game screen, our particles hang around and we can actually move in 3D space as if they are floating around with our stuff. So as long as we control the camera properly, jobs are good in here. Right, let's get to dragging and dropping our molecules so that they can connect. So rather than adding the force, we aren't gonna do anything. We're just gonna get rid of that. And And in dragging molecule, what we want to do, we want to get position of the mouse, get direction to the mouse from our position. Yep. And then we want to apply a force towards the mouse position on all our connected molecules. I think we want to do it on all our molecules anyway. Maybe I don't, but we'll see. So first of all, to get the position of the mouse, we want to do, I think we should actually have that event data dot position. Yeah, great. That's fantastic. So we can do what we want to do, we want to cache our main camera. So we'll have a private camera main camera. And in the awake, we'll just main camera equals camera.main. This is an expensive call typically, but doing it in the awake method and just caching it once is fine. It really doesn't make much of a difference. So we can do var mouse position equals underscore main camera dot screen to world point. That gives us the position of the mouse on the screen. We can then, yeah, that gives us our position. That's, yeah, great. So then the direction to the mouse from our position, so var force direction equals, this is going to be the target position, so mouse position minus transform.position, because we want to, yeah, that is what we want. And then we are going to, for each molecule in connected molecules, we are going to molecule.rb.add force direction multiplied by vector3.distance. So I want it, the further away it is, the more force I want to apply, because we want it to get there quickly. So the distance between mouse position and transform.position, and we're going to do this as an impulse. And that way, when we let go as well, it shouldn't, we don't actually need to keep track of any of the pointer up or pointer down stuff, or well, the pointer, yeah, we don't need to keep track of the pointer up stuff. We'll just, that's kind of okay. So now we should be able to just fling molecules around the place, I hope. Let's find out, I guess. It's probably going to be really floaty, which I don't like working with forces. But if we want to be able to like throw stuff, click. Oh, okay. Let me just stick the debug back in there to make sure it's actually doing the drag. Debug.log dragging molecule. Oh my gosh, did I just write Maguire? Dragging Maguire. Yeah, so the molecule is dragging. Which makes me think this force direction must be wrong. Let's log that out. And let's do normalize it so that we know things are behaving as they should. And I have a feeling this is probably going to be to do with the fact that we're using a perspective camera instead of a what's it called? What's it called? Yeah, look at that. That's tiny. This number is tiny and it's not changing. It is staying the same. That's interesting. Oh, I suppose this probably doesn't run. Oh no, it does run for every frame. I want to make sure that the Z value is 0 as well. So I can just force direction.z equals 0. I suppose I do want to make it so that things can't move on the Z axis. They should only be able to move on the X and Y. Because I don't want to have to worry about figuring out moving things through depth, which is just kind of a faff. These are at 0, 0, yep. So it only updates when the mouse is moving, or it only calls the drag function while the mouse is moving, and that doesn't seem to update the position or the mouse position the same as the thing. It's always 0, 0. Tell you what, let's do this. Let's do this kind of different. Let's do, instead of just getting the... Oh, I've just done transform.position minus transform.position. I wanted to do mouse position. But I'm still going to do it. I'm still going to do it kind of different. So instead of this, we're going to do var hit plane equals new plane. And the way that planes work is we need, yeah, the normal. So this is going to be vector3 dot back, and the position is going to be vector3 dot 0. We can then do a oh, how do you do it? I've written a script for it in the project that we're working on at the moment, which, to be fair, let me show you a little clip of what we got here. We got some procedurally animated robots. This game is called Beast. Haven't actually announced it properly yet, but for those of you who are watching, if anyone's still around, this is what we're working on. Beast stands for Battle Enabled Augmentation System Turrets. And you basically build up your weapons on your turret and survive waves of enemies in a kind of roguelike format. All procedurally animated and pretty juicy feeling. It's quite fun. And that's what we're working on at the moment. For that game, I created a script to do like get the mouse position in the world based on a plane, because I wanted everything to be able to be relative to the camera, and using 3D instead of 2D, the screen to world point doesn't actually work very well. So we are going to resolve our issue now by looking at our Shiba Dog Studio projects. The Wanna-Yam Game Jam. No, not the Wanna-Yam Game Jam. Beast. We want to look at Beast. Assets. Scripts. And I think it's player states. No, state machine code, and then the player state driver. Here we go. This stuff here. Perfect. Let's paste this in here. We are going to use our main camera, .get component, screen point to array, event data dot position. And then our look direction, we're going to rename to force direction. There we go. Oh, I need to make sure the plane's actually going in the right direction as well. It's going to be vector2.back. And vector2.0. Yeah, cool. Yeah, so my theory is that this event data isn't being updated with every drag event, which is kind of annoying. But it should be. Let's have a look here. I mean, yeah, this is fine.
Not this one.
Hello and welcome to this tutorial on moving 3D game objects with mouse drag. Here you see we have 4 die and take the mouse press on game object. Go through this window. Calculate necessary position vector check, which has mouse position x as it is x value, mouse position y as it is y value, and camera z distance as it is z value. In screen space there is a value.
We're getting the position of the thing on the screen. Why?
Points that you can tweak around with this behavior. One here, and this one's very simple one, a little runtime of the game.
I mean, I suppose this is probably the type of thing to try, is rather than doing all of this, let's just do transform dot position equals mouse position. See what we get. There we go. That's doing something. The problem obviously is that we can't like fling stuff now. Let's mathf.min this. Sorry. Max between that and 1. So what that does is return the largest of either the distance between the two or 1. Not that we really want to do that. We do want to multiply it by 0. If it's on the mouse, we don't want it to try and move towards the mouse. Because that would be weird. But yeah, it just doesn't like adding the force. Doesn't like adding the force. Which is very strange. Because the mouse position is getting updated correctly. We know that because we managed to update the position. Oh, I'm not Blah. Dingus. I'm not doing it to our own rigid body. Oh, it was probably working before. Gosh darn it. Let's have a look here and see what's happening. I think we can get rid of this mathf.max as well. I was just being an absolute dingus. Yeah, there we go. Pow. Now we can throw stuff. And we can throw it quite aggressively as well. Now we've got a molecule here. Nice. Okay, this is cool. This is cool. So I'm actually going to get rid of the bit of code that I'm having way too much fun with this. I'm going to get rid of this for loop. We don't need to apply it to all our things. We can just apply it to us. And actually, we don't want to do it in here. We want to do it in public void move towards mouse. And won't do anything. We will just take this. Command X, paste in here. I'm actually going to remove the on drag because we don't need it. We'll just do a little thing in here to say when we drag and when we stop. And in here we can actually do, I think it's mouse. Yeah, mouse.current or something like that. Yeah, mouse.current.position. There we go. Can I get you as read value vector 2. No. There we go. So we will have a private bool being dragged, and in our update method we'll say if being dragged, we'll do the move towards mouse. Being dragged equals false, and being dragged equals true. We'll only do that if event data dot dragging is true. So if we just click it, we're not going to set it to true. But if we put the mouse down and make the drag, it'll set it to true and start moving things around. And then when we let go, it'll stop. And that way it should always move towards the mouse. Oh, and yet it doesn't. Oh, come on. I mean, it's probably because of this this little if statement. I want to find out why, though. Oh, it's just not included in the... Okay, cool. I mean, I suppose I could use this instead of on down, but... We can fix that up if it gets worse. Let's stick the lights on. Getting a bit dark in here. Oh, that is bright. I wonder if that's going to have made my face really bright on the screen as well. No, that's alright. That actually looks better. I was going to take a break at 4, but there we go, look at that. Oh, that's not great. I like that it's almost like this kind of, you've got to put some effort into moving things around properly so that you don't get stuff all connected together like crazy, but this is feeling kind of cool. I like the vibe of being able to just throw molecules around the place and they connect together. There we go. So now we've got this whole structure, and obviously I don't want these two to touch because we like structures. And I can pew and stuff disconnects. Fantastic. So the next step is to well, I need to make sure stuff doesn't get close to other stuff. I need to figure out if there's a way to maintain distance from the thing that it's connected to. Which, let's have a look here.
cause a rotation. So you have this hinge joint and the motor. Next up, hinge joint.
Don't want the hinge joint, I want the spring joint.
Rotates a little bit more. If I set the anchor back to the
Oh, it's the anchor position.
It's again anchored at the top, and you see the brown spot there. That is the anchor. So put right there. So when I move it, and you can do this with every joint. So I will skip this in the next joint. Next up is a spring joint. You do not have to set a connected widget body, but it makes things a little bit clearer. Let's start with the widget body. Let's remove the ground, and I think we can start right there. The initial values are good enough for us, and here you can see it's connected to this one, and here is...
Okay, so I'm thinking what needs to happen is the anchor...
Move it. The anchor is right there.
We need to keep the anchor position...
middle. And as you can see, the anchor is in the middle. It behaves a little bit different.
At the position of the thing that we're connected to.
A little bit more. If I set the anchor back to 0.5, it's again anchored at the top.
And we'll have to make sure we do that
There,
every frame.
It goes a little bit down every time I change it here.
Which feels annoying. I don't really want to do that, but I think that's the only...
Just uncheck the box, and then it should be a little bit easier to change these values during runtime. Yes, there we go. And I can move this widget body as well, because this is
Oh wait,
values, and then it should be a little bit easier to
connected anchor. I guess that's what we want to update.
change these values during runtime. Yes, there we go. And I can move this widget body as well, because this is a connected one. If I do not have a connected widget body, then everything looks like this.
Yeah, okay, so rather than setting our min-max distance, what we'll do, or maybe we'll still do that. Yeah, no, we'll do, whoops. Connection.auto configure connected anchor equals false. And then I want to do connection.connected anchor equals new vector 3. We want it to be the direction towards the thing that we want to connect. So we'll do molecule to connect dot transform dot position minus our transform dot position multiplied by, I don't know, let's say 0.5. And that should give us a stable offset. If I'm understanding that right. I mean, maybe we do want to go 1. Yeah, let's go with 1.25. Because the radius of the circle is 0.5, so that should give us adequate distance. Yeah, there we go. Now these things maintain some decent distance from each other in the direction that they connected. Almost. Oh, I need to normalize it. And let's maybe times it by 2, just to be extra specially sure. And that everything should balance itself out. We should get some nice jelly kind of feeling thing. And I'm also going to change the drag down to like 2.5. It's feeling a bit too stiff for me at the moment. Nice. Oh, that's interesting. This is cool though. I haven't actually played around with physics quite as hard as I'm doing right now, but I'm enjoying this. This is fun. Yeah, this is fun. Right, okay. So oh. Yeah, I think there's something off with the way that I'm doing my maths for the connected anchors. Let's get you connected to him. Yeah, that's a good rule to go by. Game is fun. That's it. It's done. Yeah, I mean, to be fair, you could totally just sit around throwing these things about the place for ages. It's entertaining for sure. Oh, and they feel so juicy as well. I want to add some like sound effect. Maybe I do want to go completely flat shaded. Because oh, that's certainly improved my frame. Oh my gosh, my frame rate is so much better. I think anyway, or maybe it's not. Maybe I'm tripping. Yeah, I think I'm tripping. I need to create some like or get some sound effects for like connecting a disco. Oh, come back here. There we go. Swapam. So if I throw this like okay, they're gone. That's cool. I like how you can like slingshot other elements into things as well. That's oh, yeah, this is going to be a fun little toy. You know what? I am going to go flat shaded because I like flat shaded, which means I need to sort out my lighting. Rendering lighting. Environment. Let's get this back up to white. There we go. Nice, 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 nice. I'm going to turn off the gizmos as well because I don't actually like them very much. So what we need to do is I want to create some way of actually like merging these, like creating these bonds visibly. I think I'm okay to not play with the values too much, or mess around with the physics too much for it right now. This or connected anchor stuff is irking me. I want that to work better. I don't know if I actually need to do that. I think the anchor is 0 by default, right? Anyone in chat a Unity user? I'm pretty sure it's 0 by default. Let's just check to make sure. No, it's 0.5 by default. And yeah, so let's fix that. I'm also gonna up this distance to like maybe 3. Give us some nice space. And then for actually creating the bond, I kind of need, yeah, I need this. I need this to be some kind of data structure so that I can... Or do I? No, no, what am I talking about? Let's make... Okay, here's what we're going to do. We are going to... we're going to create a new prefab. This is going to be our connection. Let's reset its position. We're going to add a line renderer. And... I think we're using world space, which is good. That's kind of what I want to do. Yeah, good, 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 good. Materials, let's use our bond material. Let's just get one of our positions going. Where are my positions? They're the positions. I always forget. Let's move it up one like that. Let's get the width. Yeah, like 0.4 sort of width. Cool. And we're going to make a new scripts, molecule logic, right click, create C# script connection. And this is going to be really simple. We are going to public void update. We want to have serialized field, private line renderer, which is going to be our connection renderer. And we'll also have a private molecule A and B. You know what, these can probably be transforms actually. And we'll have a public void init, which is going to take in a transform A and a transform B. We will say underscore connection renderer dot position count equals 2, because we want 2 positions. Yep. And we'll say underscore connection renderer dot... Actually, we don't even need to do that. Yeah, we do. Set position 0 is going to be a dot position. Connection renderer dot set position 1 is going to be b dot position. And then, because we're using physics, I think we can do things in a fixed update. We want to make sure that we set this dot a. These need to be underscores. Naming conventions, Cuba. Come on. A equals A, B equals B, and then in update we'll just say we'll do this. Doing the fixed update. No, we won't. We'll do it in the update because we want it to behave. And then in our molecule, I actually probably want the connection to... Oh, wait, I also want to transform dot position equals... No, I won't bother with that. We won't bother with that. We'll make it purely rendering. And it might be incredibly inefficient, but I don't care. We will have a public connection prefab, and then we want to be able to store this in here as well. So let's bring our struct back. Public struct connection pieces. connection pieces, we are going to have a connection renderer and a spring joint for connection physics, or connection joint, let's call it that. These are both going to be public. Make our constructor. Connection renderer equals connection, and our connection joint equals our spring joint. And then when we create a connection, we are going to, first of all, this needs to be my connection pieces. So we create our connection. I'm going to rename this spring joint. And we're also going to have a var connection renderer equals instantiate connection renderer. No, not connection renderer. What have I called it? Connection prefab. And then we'll do a new connection pieces, which is going to take in our I've forgotten which order I did things in. Connection renderer and connection spring joint. We also want to make sure we initialize our connection renderer, so let's do connection renderer.init, and we're going to pass in transform and molecule to connect.transform. And then for our disconnection, we want to take the connection pieces. We are going to destroy connection dot connection joint and destroy connection dot connection renderer dot game object. Sick. So now, if we make that a prefab, there it is, prefabs. Let's make, I mean, I suppose we can make these on later. It might save on some rendering, but yeah, we'll get back to it. So we want to go onto our molecule. We're going to set our connection prefab. Oh, I need to actually put the connection script on it. Connection. There's our line renderer. Put the connection in there. That's now updated on all of these. We'll delete our connection from here. Hit save. Let's see what we got. Ooh, there's a connection. Boom, there's another connection, and even more connections. They look like rubber bands. But they are pretty cool rubber bands, and we can like drag the whole thing around. Oh, that feels so good. No! Nice. Okay, so I want to make the connections thinner. I also want to make them green instead, because I think green looks nicer. And you know, let's darken it up a little bit. Maybe like 20, give it some extra saturation, and I'm gonna make that much thinner because it's way too thick at the moment. We're gonna make it like 0.2, And we're also going to reduce this distance down to 1.5 because I think it's way too big. Threatening anchor point to the correct place. And I want to reduce this force as well to like maybe 2.5. And let's set the damper to like 0.75 and set the spring to like 5. Maybe we want the damper to be like, I don't know, 1.25 actually, a little bit more sturdy. And then I think we might be good, you know. At least for now. I think I'll call that the end of this initial stream, and we'll come back and do some more either later or tomorrow or on Tuesday. Yeah, look at that. There we go. Like little cherries on sticks. And I like as well, if they like overlap with each other, we should still get some ambient occlusion. That's fun. Nice. Yeah, we still get some ambient occlusion on there when they're overlapping, which is cool. A little bit of depth. So yeah, that's why we still use the lit shader instead of completely unlit. Oh, I need to fix this bug as well. Because that's, that ain't it. So what we'll actually do, we'll just do a, we'll do a little check here to say if, you know, well, let's cache it as well. Distance from mouse equals this. Oh wait, I think I've just been being an idiot again. I don't want to apply the max, I just want to apply the distance. We're gonna have to do something about the way that bonds work as well, because the offset position isn't quite working as well as I want it to. I want it to be able to maintain distances rather than being forced to maintain the direction as well. Yeah, nice. Cool. So now we've got these juicy feeling particles. They follow your mouse around. You can sling them. You can actually get some real force behind that. And we can use that for, we can determine the velocity to create different types of bonds. I think is going to be the approach. It's that. I want it to just stay the right distance away, not the right direction. Although maybe we do want directions as well, so that you can actually, maybe you could be smart about it and build things together. Like here we go. Let's say I want a molecule like this, and then on this end we need like this kind of shape. You go on there, and then you're going to go on the bottom here. And now we've got this whole whole thing that we can pull around. Yeah, this is enjoyable. This is enjoyable. Cool. All right then, guys. That's gonna be the end of part 1 of this little jam. So we've spent what, like, nearly 3 hours setting this up, but it looks good and it basically does everything that we want it to do. We can form connections. We can drag our molecules around. We can position things how we want them. I can make a little box here if I want to. Let's do it like this. Yeah. Connect you on there and connect you on there like that. Nice. So I think next steps are going to be, we want to be able to figure out a way to look at these shapes and kind of determine, based on the connections, how many connections each thing has and what type of element each thing is. We can look at that structure as a whole and say, yeah, this is this kind of molecule, or this kind of, I think it would have to be molecule. And I think what I'd like to do is, if we have different, like different elements, so we can have like water, like a water molecule, a fire molecule, all that kind of stuff. And you can attach them in different configurations and create different stuff. So thank you very much, everyone who came along to this one to watch. Like I said, I know I've been gone a while. I'm going to do a video to explain why very soon. I do want to do more of these. I'm going to aim to do streams on Tuesdays and Saturdays relatively consistently. We've got like nearly 2 weeks to finish this game off, so I think we should be in good stead for creating something cool here. And yeah, let me know in the comments if you've got any ideas for fun molecule combinations. If you're not already, be sure to join our Discord server. We're trying to bring it back to life for my massive hiatus, but there should be a link for that in the description if you're interested in hanging out. If you did enjoy, leave a like, subscribe, all the usual stuff, and we will do this again real soon. Thank you very much, guys.